is a weekly update from Mr. Fix's science class for the week of March 4th. Alright, so this week we did a pre-unit assessment for magnetic fields unit. There's 18 multiple choice questions and 2 written responses, and they also did a magnetism, magnetic forces Edpuzzle that was scored and entered into the gradebook. Alright, we did lesson 1.2, introducing magnetic spacecraft. Alright, so the students had a little prompt to think about magnets, how it could maybe cause something to move. And then we got into the kind of problem of the unit, and it was all about launching a spacecraft via magnetic system. So here's a little taste of the video. Alright, so basically what they were testing is they discovered on one day they moved the magnetic launcher system closer together by 1 centimeter, and that caused a 10 meter per second change in the acceleration. And then they did it on another centimeter again, and that increased by 30 meters per second increase in speed. So that was kind of the problem we're trying to figure out. And so here's the main crux of the problem here, visually represented. Alright, so then students, what they did is they wrote down the unit question on page 20 of the reference notebook. Our chapter 1 question is, how can a launcher make the model spacecraft move without touching it? And then we investigated the question, how do magnets make or move objects? And so we had a strong and a weak magnet. We had a wooden popsicle stick, aluminum foil, paper clip, a penny, and a nickel. And they explored how these various objects were affected by magnets. And basically, they did this also in the sim as well. So let me take you to the sim, show you that for a little bit. Alright, so the sim, they got to explore and figure out what features the sim has, and then they played around the sim and saw what happened with various magnet combinations and various materials combination, etc. So here's our second magnet here. We run it and we see what happens. So they played around with that, and basically we discovered that magnets can make things attract, pull objects toward one another. So we copied that down to page 21 of our reference notebook. And then we also learned that magnets can repel. So in other words, push objects away from each other. So let's take a look at the notebook real quick. So it takes us to, whoops, that's not the correct one. Let's go back here. Alright, so the correct notebook link here is right here. Oops, let's go back. So we click on that link, and here is the magnetic fields bulletin board notebook that they could copy down. And so they copy down the unit question, chapter 1 question, and the key concept: magnetic force can attract or repel an object at a distance. And then we have some vocabulary words that we copied down to in that first lesson. Alright, so that was lesson 1.2, and then we did lesson 1.3. Let's take a look at the slide deck there. Alright, so this is about evaluating magnetic force evidence. And so Barry had a situation where he had a claim strong magnets repel and weak magnets attract. He did some experiments, and this is the evidence he had. He's had test number 1, where the results were, here's the setup, and the results were the magnets moved away from each other, and then here's the setup for test 2, and the result was that the magnets moved toward each other instead of moving away from each other like test 1. So we talked about magnetic poles, the 2 opposite ends of the magnet. Again, that was on page 21 of the reference notebook that I copied down. And the bar magnet, this red end is the North Pole, the other end is the South Pole, so we learned about that. Alright, so how can you tell whether 2 magnets will attract each other, repel each other, or both? So we discussed if students agreed or disagreed with Barry's claim based on the evidence he collected. And we looked at, hey, there's some problems with the way he collected the evidence, and so there's definitely a way to improve the experiment. So we learned about variable, something that can be changed and maybe measured. So Barry's trying to test the variable that the strength of the magnet determines whether the magnets repel or attract to each other. And isolate means to separate or set apart. So the big question was, well, did Berry isolate the variable of magnet strength? And so evidence criterion, evidence is stronger when the variable being tested is isolated so that only one variable is changed at a time. So Berry didn't really do that, because if we take a look at it, let's look at it real quick. There we go. Berry, between test 1 and test 2, he used different strength magnets, and also he changed the alignment, so he didn't isolate the variable of the magnetic strength. So this was not strong evidence that he created. We don't know if the results were due to the fact of the magnet strength or the alignment of the magnets. So this is poor evidence, basically. And then students were given 5 evidence cards and taking a look at it. So let's take a look at it. They opened up their own copy, and they were trying to figure out, well, how many variables were changed for the second test. So let's take a look at this one right here. So we have position of the magnets is, for test 1 and test 2, is the same. The same poles are aligned with each other for test 1 and test 2. And the only difference between the two is that test 1 was a strong magnet and test 2 was a weak magnet. So this is strong evidence. Only one variable is tested and isolated. Let's take a look at this one, where we have same magnets, same strength, they're both weak. The alignment from test 1 is different from test 2, so that's changed. But also look at the distance. The distance is farther in test 1 and test 2, so probably a little bit less strong evidence. All right, so they had to sort through all those evidence cards. All right, so then we clicked on they had to identify which claim is the strongest piece of evidence to share with them. So we took a look at that. And then they modeled the system of magnets. So the scientists often use models to illustrate their ideas about how something works. So we used a modeling tool to show our ideas of how the interaction between magnets in a system. So vocabulary word we also copied down on page 21 is model, an object, diagram, or computer program that helps us understand something by making it simpler or easier to use. Then system, a set of interacting parts forming a complex whole. And so each system is a group of parts that interact in a particular way. So this is a system of magnets right here. All right. So they used a modeling tool to create 2 models that will describe how magnets move in response to magnetic forces. All right. So here's an example of the magnets that the poles are aligned in opposite ways. And so held in place, and then after releasing the magnets then moved in the direction. So that was an example of how to do it, and then they did it for the other way. When the poles of the magnets were aligned in the same way, they had to do that. And so we went over that as well. Then when you wrote down key concept number 2, in a system of magnets, there's a repelling force between like poles and attracting force between opposite poles. And then they had some homework that they had to do. All right, then we did magnetic fields lesson 1.4, Earth's geomagnetism. A little warm-up, a little active reading, and discussing some annotations that they made. So that's basically what we did this week. Hope you have a good weekend. Bye-bye.